Welcome to the third video on building your own private, secure compute environment. In this video, we'll talk about really the heart of any kind of environment you want to build, which is the network. And what the network is going to look like is going to depend a great deal on what it is you're trying to get out of it. Your needs are going to dictate what the network needs to look like. Are you going to have things where you need to be able to get in remotely? Do you want to have security cameras? Do you want to have um, a guest network? And it goes on and on. So we'll talk about the kinds of things that will go and affect what you want your network to look like. And then we'll go into and how do you set it up based on your desires. But the first part is always going to be having a network plan. And from personal experience, I can assure you that your first plan will not be your last plan. You'll put it together and say, oh, I'd really like, and then you're going to modify it. It'll take a couple times before you get just what you want to have. So let's just talk about this in general terms first. We'll talk about a bunch of subnets. You remember each subnet is a separate network that can only talk amongst itself and may or may not have a gateway. And one of the first subnets to talk about is the LAN, which is the local area network. And that's generally what people use for the trusted internal network. That's where you'd have your computers, your printers, and other trusted devices, perhaps your phone. If you've got multiple people, then it'd probably be multiple computers in there, maybe multiple printers, and usually things that you are pretty sure aren't going to be leaking out on you. A little side note, if you have a printer, you probably want to put a firewall rule in there to prevent that printer from talking out. Printers have been known to start leaking data that you really don't want to be leaking. We'll talk about that a little bit later in the firewall section of this video. So the LAN is likely to be the first one you want to have, and that'd be sort of the generic what you expect to have in there. What you probably don't want to have are IoT devices, your refrigerators, your smart televisions, your robo vacuums. Ring cameras would fall into this category because a ring camera is a kind of security camera where you don't control the data and you don't control how it works. It talks out, in the case of Ring, it talks out to Google, but I'm sure there are other devices where they talk out to some external server, and that server owns and controls the data, not you. Later, we'll be talking about how to do this without having somebody else control that data. But those are the kinds of things you might want to put on an IoT subnet. The IoT subnet is capable of talking out. It has to in order to work, but it's separated from your computers and things of that sort. So if anything gets hacked in there or tries to go and take a look at your computers, it can't do it. It sees other IoT devices and it sees the internet and nothing else. So I usually call that IoT because I'm ever so clever. A third subnet, I should say, that you might want to consider is if you have security cameras where you're controlling the data. So I use a bunch, and these are plain IP security cameras. In fact, I usually make them IP security cameras, which means they're internet protocol, and I use something called PoE, which is power over internet. And that way, my security camera has a single Cat 5 or 6 cable that goes from my switch to the security camera, and it provides power to the security camera, and I only need one wire to do it. There are others where you plug the security camera in, and then you have the security camera talk over Wi-Fi. And if you're a long ways away, that may be the only practical thing to do, and that's fine. It'll work too. But if they're IP security cameras, then they are not talking to somebody else's server. Now you want to have them talking to your server. And for that, I like using a separate subnet. Let's call it security camera subnet or something of that sort. And that subnet lets all of the security cameras talk to one device that's on that subnet, which is the security camera software. So I put the security camera software on that subnet so that it can talk to security cameras. And if you remember in our last video when we talked about Ethernet, we talked about having a gateways that tells everybody on some particular subnet how to go outside of the subnet. And for this one, I don't want my security cameras to talk out because they will talk out with my proprietary information to whoever the manufacturer is of that security camera, presumably. So I simply don't put a gateway on that subnet. And we talked about DHCP servers, and here we'll talk about setting up DHCP servers in a little bit. And what I do is I have a DHCP server on the security camera subnet provide IP addresses and not provide a gateway. Now, without a gateway, no device can talk out, so it can't call home and say, oh, by the way, here's some videos for you to look at. Now, a security camera could conceptually say, well, you didn't give me a gateway, but I know the address of the DHCP server, so maybe I'll just try using that as a gateway. And that might work, which is why when we talk about firewalls, I like to put another firewall route in there, which simply says this subnet is not allowed to talk out. And that way, if they decide to try to sneak past the gateway, it won't work anyway. So I lock it down so that subnet does not get to talk anywhere. And that's obviously useful for security cameras. There might be other devices you have where they need to talk to other things, but you don't want them talking out. Generally, that might be a good place to put it. But we'll talk about the other method of blocking things from talking out, which is simply firewall rules. So for example, I mentioned the printer. What I do is I set a static rule for the DHCP so that my printer always ends up on a specific IP address. And then I put a firewall rule and says, oh, by the way, that IP address is not allowed to talk out on the internet. I see no reason for a printer to be able to talk out. Occasionally, it'll need to do an update. I might then let it go do an update if it needs to do that, but actually, usually I can have the update done through the PC and avoid that. And again, this is all flexible. You're now designing your network, and my only job here is to give you ideas and methods and how do you do it while you decide what it is you want to do for your particular needs. The third subnet that can be kind of useful is very simple. It's a guest network. This can be useful for friends that have come over who, they don't want to share a subnet with IoT devices, and you don't know what's on your friend's computer. Did they get hacked at some point? Do they have viruses on their computer? I don't want to ask. I keep them on a separate subnet. I don't need to know. And on that subnet, you can do a couple things. You can either simply say everything on this subnet is allowed to go out, and the firewall will prevent anything from coming in. That's kind of like the standard that you get from your basic modem setup from an IP, from your internet provider. And that's usually just fine. You might decide that you want to be stricter for some reason. You may decide, I only want to have web browsing go out. So I'm going to allow port 80 and port 443 of TCP to go out, if you remember our internet video, last video number 2. And that can be limiting, but it could basically prevent a lot of hokey things from going on if that's a concern of yours. In my experience, you have a friend come over, they need to do some work, they have a corporate VPN, that corporate VPN uses some crazy port numbers. Yeah, I could try to go figure out which ports I need to allow for it. I don't bother. If you're going to get onto my guest network, I'm assuming you won't do anything terrible. And so you just have access out from the internet from there. And that's worked well for me. And now I want to talk about the one odd one. If you decide that you want to have security camera software, so software that captures and analyzes your security camera footage, and you want to be able to access your security camera footage from wherever you are. You're at work and you want to be able to see what's happening in your driveway. Then you're going to need to have remote access. You're going to need to have a way to get from the outside world into your own security camera software in order to go see the footage or see something alerted me. What alerted me? Let me go see. And that means you've got incoming data, and we got to do something special with that. And the other place where this will be useful is if you decide to run your own cloud server and you want access to your cloud data when you're on the road, that too is incoming data. And for that, what's used generally is called a DMZ, a demilitarized zone. It's a separate subnet that is separated from your internal LAN and separated from the internet, and it contains just the devices that have to both accept data in from the internet, i.e. the requests for either cloud data or for security camera footage, and accept requests from internal. Same things. I want to get my cloud footage. I want to get my security camera footage. And that's what generally is called the DMZ. You can call it that. You could call it something different if you set it up. But here you'd have another subnet, and the only devices that should go into that subnet are devices that need access that need to be accessible from the internet outside of your own LAN. And that's not too hard to do. And we'll go through all the rules of setting that up as well. We're going to do something called port forwarding. If you have a modem or an internet service provider modem, you usually have to forward ports in order to get to it. And we'll have to do some level of router setup to say, oh yeah, these ports are going to be allowed from the internet into these specific ports of these specific IP addresses inside the DMZ. And that way, even though the internet can get to those devices, they can only get to them in very specific places. So you'll generally have to allow HTTP, HTTPS, and what I always do for my security camera software is I put it on some other port. And I'll show you, one, how to do that, and two, how you then access it if that's new to you. And one other thing I'll mention here is the minute you're doing this, you're into a functionality versus security trade-off, right? A DMZ in some ways is weakening your firewall because it's allowing ports to come in. On the other hand, it's giving you critical capabilities, right? You can get your data from your cloud storage when you're traveling, which can be really important. I certainly have to do it all the time. So that's one of the trade-offs. And the other trade-off is going to be a bit of a cost versus security trade-off. In the fourth video, I'm going to talk about setting up your own cloud server, and that's going to be a piece of community software that goes onto, I'm going to show you how to put it onto a Linux server. And in the fifth video, I'm going to talk about how to go set up security cam software that captures, analyzes, and reports on what all your security cameras are seeing, which is also a piece of free software, and also runs on a Linux machine. Ideally, these would be on two separate Linux machines from a security viewpoint. Not because there's inherently anything insecure, but because if for some reason there is a security hole in your security camera software, it could conceivably be used to tunnel into your cloud server. And so any corporation would have security camera software driven by one computer and the cloud computer software driven by another computer. In home environments where cost, space, power may all be considerations, there's no reason you can't put them both on the same computer. Just recognize that you have a bit of security versus cost trade-off. And this again it's your call. I'm just going to try to show you your options. And by the way, if you're truly concerned about your data that's on your cloud server, this cloud server that I'm going to introduce does support end-to-end encryption, which means the data being stored on the cloud server is entirely encrypted and the cloud server can't read it. It gets encrypted on your laptop and decrypted on your laptop. That's got some advantages and some disadvantages that we'll talk about. But basically, if you have all of your data encrypted on your server and you're trying to back up your server and something is a little odd, you can't read the files. You can't even read the directories. It's just a lot of random things, and what's what is very hard to see. So it gives you better security, but can also give you a bit of a headache if for some reason you're trying to figure out what's going on. But nonetheless, that's a topic for video 4. Sorry, I don't want to take my thunder away there. So you'll have these two machines, and it may be one machine, it may be two, but it's a trade-off that is likely going to look different between a home and a small office environment. And then those are sort of the standard subnets. You may decide that you want to add some other subnet or some other reasons that you may have, and you can have pretty much as many as you want. I mean, VLAN identifiers go up to about 1,000, but I would really, really recommend you don't do that because you will be very confused by the time. I'm okay with 5 or 6. I have a hard time figuring out what I was doing with them once I get past that. I'll just mention one other subnet that I use, and that is for Wi-Fi access points. I have some Wi-Fi. I'll talk about which Wi-Fi access points I like in a little while, but I have access points from 2 different manufacturers. And anytime that you buy internet equipment, you probably want to look at the manufacturer and ask, where was this built? Who is the actual manufacturer? And one of my Wi-Fi access points was manufactured outside of this country, And there have been reports of that company having manufactured equipment that may or may not leak data back to the manufacturer. And a Wi-Fi access point could conceivably have access to all kinds of data. So you might be wondering about what you want to do about that. And what I do is a little bit odd, but it makes me feel better. I can't prove that it's actually better or worse, but I put the Wi-Fi access points on a private subnet that cannot talk out. And it allows communication between my router and the Wi-Fi access point. And that's it. So the Wi-Fi access point can't go out to the internet, and it can't talk to any other devices anywhere on its own. And then I use VLANs for all of the networks that I'm using through the Wi-Fi access point. So the Wi-Fi access point is aware of the VLANs, so conceivably it could hop onto a VLAN and send data that way, but it would then need to set up an IP address to do that, and I can see that it's not setting up IP addresses. So anytime I want to talk from my router to some devices on a Wi-Fi subnet, I put them on a virtual LAN with a LAN identifier that's not one, i.e. not the base subnet. So now my Wi-Fi access point can talk to my router back and forth. It cannot talk out. But yet the devices that are connected up to the Wi-Fi access point can, because they're not connected up to that base network. They're connected up to VLANs running tunneled through that network. I'm not sure if that makes sense. And I'm also not entirely sure that it buys me additional security, but it makes me feel good. So I can show you how to do it later on, and then you can decide if you want to do that or not. That's really up to you. And by the way, when the Wi-Fi access point needs an update, well, then you got to go and open up a port so the Wi-Fi access point can download the update in order to go and get its updated software. And then you close that port access back down. That's a basic introduction to networks. I want to bring up a few more concepts that you're going to have to make some decisions about, and then we'll go into the mechanics of setting up a router and a firewall. And one of the decisions is going to be Wi-Fi or wired. And that may very well be decided by you have no wires and you really don't want to put wires in. Well, now you know which way you're going. If you do have wires in the house, then you may decide that some of them are useful, but you want to have some devices that are just hanging there. So you might have a mix of each. And for each subnet, you can have a mix and match, whatever you want. Like I said, I like to have my security cameras wired. It makes it harder to interfere with them. I have to bring power in anyway, so I might as well just bring power in on the Cat6 cable. And I like to have my main computers wired. I don't really want a computer that I'm doing sensitive things with to be Wi-Fi-able. That's my personal preference. If it's Wi-Fi and you have a reasonable password on it, and you're doing everything via encrypted, so if you do HTTPS, all of your data is encrypted anyway, it's sort of a pick and choose kind of a thing. But you will need to be doing some kind of backups, and you will need to have your data being, now if you have cloud computing, backups become easier because you just have to make sure everything's stored on your cloud and your cloud is backed up and you've got all your data done. And if for some reason your computer dies, everything you needed is on the cloud. You just plug your new computer in, log into the cloud, say, get me all my stuff. There it is. Personally, I like it because I can switch to a new computer anytime I want. And yeah, it takes a few hours for it to all go and load up, but I don't have to do a whole lot. I nonetheless like wired. It's faster and gives me a little bit more security. Not a lot, especially for home environments. Wi-Fi with WPA3 is going to be fairly secure. I think we're next ready to talk about the router. I'll be using PfSense, and PfSense has to run on a x86 PC. As I mentioned in the introductory video, as I mentioned in a previous video, you have a lot of choices for using a PC. You'll need a hard drive, 32 gig, 64 gig, something along those lines should be sufficient. A little bit bigger lets you do a little more for DNS blacklisting or for a variety of other options that PfSense supports. And If you're purchasing one, then you'll need a minimum of 2 Ethernet ports. You'll need one for the WAN, the wide area network, where your internet comes in from, and you'll need at least one for LANs, that is local area networks. If you only have one local area network Ethernet port, and you want to have any kind of division at all between IoT devices and your compute devices and other things you want to have some level of protection on, then you're going to be using VLANs, virtual LANs, in order to have a bunch of different subnets, even though you have one Ethernet port. And that's no problem. That'll work just great. You'll just take that one Ethernet port, you'll bring it to a smart switch, and from the smart switch will then branch out so that you'll have some ports that are in one subnet and some other ports that are another subnet. It'll break the virtual LANs, the smart switch will break the virtual LANs into a bunch of independent LANs underneath. So that'll work great. And so with that in mind, I'm going to start the installation with a ISO of PfSense downloaded from the internet, put onto a USB stick so that it can be booted from the USB stick, and we'll start the installation. When we boot from the CD-ROM, we'll see a window sort of like this, except you'll get about 2 seconds to look at it because it doesn't auto boot in 2 seconds. And then it will start up. And you'll note that it has all kinds of stuff coming through here, which looks pretty intimidating, but is actually the same thing that you get with any Windows or Mac OS boot as well. It's just you don't see it. They hide it all from you. But every time any system is first booted up, the first thing it has to do is look around and see what it's got. How many Ethernet ports does it have? What kind of memory does it have? What are the features within the processor? That's all those kinds of things. At any rate, you then need to go and accept the license agreement, which we can go do right there, and then have the option to install PfSense, which we're going to do. And once it does it, it's going to try to set up the network first. This particular machine had 4 Ethernet ports. The first thing it needs to know is which port is the WAN port, that is the one that is connected up to the wide area network, the internet. And it needs to know that because it needs to connect up in order to go and get the latest software updates. So as we have this going, you can now see it. So you can see where we're connecting up the WAN port. And then once we've connected up the WAN port, it will go out to the internet because it wants to go and load extra software. So in this case, there is no PfSense subscription, and instead we're going to install the Community Edition, which is the free edition. We get no support on it. We get no additional stuff. We just get a beautifully, fully functional firewall and router, which is great. By default, it's going to use ZFS. We're going to talk about that in video 4. Don't worry about it right now. Go with the defaults. And we're going to go and start this thing up, and it's going to now take a whole bunch of time to go and install. We can select which version. I always just use the current stable version. I've never wanted to use a previous one, so that's great. And off it goes. And you'll note that it begins to get a whole bunch of packages, and it's going to take a whole lot of time that I'm going to not bore you guys with. So we'll just skip to the end, and when you get to the end, you're going to see this window, which is basically it's gone through, it's rebooted, and it now comes up with the basic prompt. And here you can do operations either this way, which is really icky, or you can just go to a web browser and access it from the internal LAN port in order to go and do it via web instead, which is much easier, much more user-friendly, which we're going to go to next. Once you've got PfSense installed, and you can see what the IP address is of the LAN network, and you can go and plug a laptop into that LAN network, and you should be able to go and do an HTTP to the usually 192.168.1.1 is the default if you don't do anything else, and you'll see a screen that comes up that looks sort of like this. The default password is PfSense, so we do admin for username and PfSense for password, and we sign into it. And no, we don't need to save this password because this is temporary. And the first thing we see is a admin account password is set to the default value. Change the password in the user manager. But right here, we sort of see the basics of what's going on. We have the default name is PfSense at home.arpa. That's just what it comes up with. This is a default user, and this happens to be the local address I'm using. And the reason this is such a weird looking one here is because this is running on a virtual machine. So it actually is not on a real piece of hardware. That makes it much easier for me to record all of this. We have a BIOS in there. We have a release version. And you'll note that right away we have a new version that's up to date. And what you can do is click on this and it will go and install your new version for you. And that's always worth doing. One of the things I'll mention is anytime before you install a new version, you'll want to do a backup. And since we're here, we'll just go into that real quick. We can always click Diagnostics, Backup and Restore. And I tend to back up everything, so I do not skip any packages. I do not skip anything at all. It's still not all that big. And you can encrypt it if you want. You don't if you don't. But then when you click this, it's going to download a file that will let you do a restore from that file should you need to do that. So if you get your network all set up and you like it, do a backup. Any rate, let's go back to System, General Setup, and we can name our host name whatever we want to name it, and we can give it a domain name. And this is really going to be useful if you actually have if you use Dyn DNS or something like that, so you have a name that gives you access from the outside world, then you probably want to set something up here that works from the outside world. If you don't, you can do this. You can call it whatever you want. I use an internal one. I call mine with my name .lan, and I use LAN, which is non-existent 3-word top-level domain, and I use it for all of my internal machines that I want to have access to. But you can do kind of whatever you want there, as long don't call it google.com, because then it's going to get confused because it really is a google.com. DNS server settings. So I've talked a couple times about Quad9 and Cloudflare and OpenDNS, and you want to choose what you want to have for a DNS server. I'm just going to pretend it's Quad9. So we're going to do a 9.9.9.9, and the host name for TLS is, I think it's quad9.net. Let's hope so. And I'm not setting a gateway for it. And you can add multiple DNS servers. It's usually good to have a couple. This one is kind of important if you're worried about privacy. DNS server override. So this one basically says that right now the DNS server can be overridden by DHCP. What does that mean? Remember that the WAN port is the port that is connected up to your internet service provider, and your internet service provider will give you a DNS server, and that DNS server will be their DNS server. So if you want to not be sharing all of your accesses to any site whatsoever, then you probably do not want to allow server override. By unclicking this, you're saying use this one, and you might want to have 2 or 3. Every DNS server that you choose will have a primary and a secondary, and you can go and look it up on the web to find out what quad9.net is. If you choose Cloudflare, same thing. If you choose OpenDNS, same thing. If you choose a different one, same thing. You want to have at least 2 in there. The other important thing I'll say is if you are using a VPN and privacy is important to you, then you want to be using your VPN provider's DNS server. And the reason for that is because only that way will everything be tunneled through the VPN. If you use 9.9.9.9 as your DNS server and you've got a VPN enabled, well, you're still doing searches on Quad9. So for maximum privacy, you'd want to be using the DNS server that is recommended by your virtual private network supplier. And I'll also point out that there's something called DNS leaking, which I might make another video about. If you're interested in that, leave me a comment. I will go and make a quick video on how to check for DNS leaks. So the other thing is here, DNS resolution behavior. We are going to use the default DNS 127.0.0.1. Remember, that's this machine. That's local loopback address. And if that fails, then we'll fall back onto the remote DNS server that's specified up here. So the idea behind that is we're going to be running our own DNS resolver here, and we'll only go outside of our own DNS resolver when it can't resolve it, and then it'll go up to the DNS server. Time zone, you can set your time zone. So if you're in Europe, if you're in Pacific, if they're in US, I'll just do one for me. We are in US Pacific right here. Time servers, this sets up, goes to PfSense, has a pool.ntp.org. Look up time servers. Basically, you'll want to have one that, I'm sorry. Let me just back up a little bit. A time server is basically a machine that all it does is if you query it on the NTP service, which is a standard protocol, it will give you the current time. I believe that's a UDP protocol, and it's a UDP because it really doesn't go and check to make sure they got right. You just send out the query, you get the current time back. And that's kind of useful because it means that all of your machines can go and get time, and everybody knows what time it is. And so, especially when you're doing backups and things like that, it's really important that all the machines agree on the time so that a backup server or multiple machines talking to that are sharing data know, oh yes, I checked this in at this time, and everybody knows what that means. So time servers are a good thing. Use them. Webconfigurator, we're just using the PfSense. I don't think there's anything particularly. You can go and modify what this thing all looks like. How do you want it sorted? How many columns? I'm going to let you go and choose the kinds of things you want here on your own. And we have a dark blue login page, and that's important to some people. And the only other thing I think is going to be in the advanced. So we're just going to click save on here. And we've saved it. Okay, so in the password manager, the password in the user manager, let's just click this so that it stops with that stupid warning. Our username is admin. We're a system administrator, and our password, because we really are never going to use this for real, is 1234556. Do not ever use that. 1234556. Like I say, this is in a VM machine. You can set an expiration date for your password. If you leave blank, don't let it expire. A lot of security people say that having expiring passwords actually puts you at more risk, because now you've got to remember multiple passwords, and then people start doing weak things in order to remember multiple passwords. If you don't have any reason to think your password has been leaked, just leave it alone, in my view. But that's up to you, of course. And custom settings and group memberships, all I have right here is an admin. You feel free to go and mess with that. Right now, you can, by the way, use an authorized SSH key. It's a great practice to use SSH to log into things and to use predefined keys. So you have a public key and you have a private key, and you put the public key into the places where you want to log in. So here we'd put a public key in place, and when we do an SSH login, you'll have your private key on your machine, and this site will then automatically check it against their authorized public key, and if they match, then you're allowed to go in automatically. That is a really nicely secure way to get into machines. The main challenge with it is that that's great for 3, 4, maybe 5 users, but once you get past 10, it starts getting really hard to manage all those authorized keys. So great for home, great for small office, emphasis on small, but on the other hand, you probably don't need that many, even in a small office environment, you probably don't need that many people who are logging into your firewall. That should really only be 1 or 2 people. So if you're interested in having an SSH tutorial, again, another comment, because I wasn't planning on covering it here, but I'm always happy to add a video if that would be helpful. And so we're going to save that now that we have 123456, and no, we are not going to save that password. And we're going to go back to system and general setup. I think we've gone through the basics in there. If we look at advanced setup, then here we can say, oh, by the way, I want the protocol to be HTTPS when we go to the web configurator, which is where we are right now. I'd always recommend that be used instead of HTTP. That way, nobody else who happens to be sitting on this network can use it. I'm not going to do that right now because I'm talking to a virtual machine. This isn't a real setup. You can also decide by default, remember, HTTPS is by default port 443, and port 80 is by default HTTP. You can decide to go and put it on some other port. Why would you do that? Maybe you have something else that is HTTPS on this machine. I sure hope not. You might think you get a bit more security by hiding it. Unfortunately, you really don't. And the reason is that security by obscurity, which is what that's generally called, tends not to be very effective. Anybody doing a proper net scan will check all of your ports, and if they find an open port, they can pretty quickly figure out, oh yes, that's an HTTPS port. You really haven't stopped anybody from doing anything. So my take is just leave it on the default port. Maximum processes defaults to 2. If you are going to allow more people in and you want to have multiple things going on, you might want to have a little more than that. And the rest of these are probably okay as is. Allow GPU administrator client to change during a login session. Yeah, I think that's probably fine. Anti-lockout. This one you probably want to leave. What it does is it enforces firewall rules so that from the LAN you can always get to this admin panel. And that's sort of called the anti-lockout. You can't make a mistake in your firewall rules, so suddenly you can't get in anymore. Personally, I think it's just fine. I don't see any reason why you would not want to do that. But that's, of course, up to you. If you have a group where you're putting people on the LAN that you do not necessarily trust, then you might want to look at that. Personally, I'd recommend you leave your LAN alone and go find another subnet where you put your users so that on that subnet they don't have access to the firewall. All of these other gets more into more types of, you can enable your secure shell so you can do an SSH into this machine. Useful to some people. Personally, I never use it because it's my local PfSense firewall. I use it on the local LAN. It's the only way I can get at it. I just go at it from the web access like this. So we're just going to save that. I'm not sure if I made any changes, but that's okay. And I'm just going to point out some of the other things first, and then we're going to get into some more detail. So in this system, there are a couple of things you can look at. You can look at high availability. That's really only going to be for an office environment where you have independent internet sources available and you want to have one switch to the other in case of a failure. Package manager, that's going to be somewhat important. There are packages you can install that give you additional functionality. Register, if you are using a registered version of it. In this case, this is just the temporary, so there's no such thing. Updates are going to be important when you want to go do that. And you can have multiple users have access to the browser. Interfaces. Here we can see the assignments we have. I've only set up the WAN, the LAN, and I set up one optional one. And right now we're running on the LAN. But this is where you're going to want to have all of your subnets defined. Once you've decided I will need the following subnets, and they're going to be either virtual LANs or they're going to be actual physical ports on physical interfaces on this thing. This is where you're going to set them up. Firewall. Here we're going to talk about the rules. Aliases are a very convenient way of giving names to groups of things. So if you have security cameras and they're going to be 192.168.5.10 through 192.168.5.30, well, that's an alias. We'll just go take a quick little glance at that. You can set up aliases for IP addresses, like I just said. So here we could do an alias, and I'm going to call it security cams, and I could have some description here and their hosts, and I can have 192.168.5.1, and I can then add 192.168.5.2, etc., etc. So now I have 2 security cams, and that's going to be useful because in the rules, I can now basically say, oh, I want for the source security cams or for the destination security cams, and it'll automatically connect up to whatever this is. If I add a camera, I don't need to change my firewall rules. I just come down here and change my alias to say, oh, by the way, I need 192.168 22.5.3 as well, and all the rules will be changed to fix that. And you can do that with ports as well. So you could say, by the way, for ports, I want to have allowed outgoing TCP, and I want to allow port 80, and I want to allow port, I want to edit that, and I want to allow port 443, and I might decide those are the ones I want to have right now. So now I can say, for my firewall, for my outgoing rules on some subnet, I want to allow only my outgoing TCP ports on protocol TCP. And then I might similarly have outgoing UDP ports, for instance. And again, the nice thing about this is going to say, oh, I really need to add another port, or I really want to take a port away. You don't need to mess with your firewall rules. You change your alias. So the nice thing about this is that it gives you a way to, and if I apply change it now just has all these. If you had rules on this, by the way, then when I apply changes, all of the firewall rules will be changed based on the change in the aliases. So aliases are a really nice way of managing firewall rules in a way that, one, are going to make your firewall rules more usable, because instead of thinking, what was 192.168.5.1, I forget, it'll be security cameras. Oh yeah, I know what those are. So we'll talk about NAT later. NAT is network address translation, and that's for the rules for incoming things. Right now I want to do just a very basic overview of things here. So here we're going to look at rules. And we have a WAN, and it has some default rules put in that basically automatically blocks private addresses from going into the WAN. And that means nobody's going to try to come in and with a port 192.168.1 does something. And there's some long ago network hacks that kind of did that. I'm not going to go into that other than just leave them there. They're great. And here we have some anti-lockout rules that basically says the LAN is always allowed to come in on port 80. And we're going to allow the LAN to IPv6, can go to any LAN subnets, and we're going to allow IPv6 and IPv4 to go to any LAN subnets. And the source is any LAN subnet, and basically anything is allowed to happen. Personally, I'm not very happy about rules like that, so you can decide you want them, you can decide you don't want them. Let's look at adding a basic rule on the LAN. So I might decide early on to add, and by the way, I'm going to just back up on that real quick. So you can add a rule at the top, you can add a rule at the bottom. You can delete a rule, but you can also delete right here. You can toggle the enable disable. You can also toggle the enable disable right here. All a disable does is say, don't delete the rule, just make it inactive. This lets you copy a rule, same as there. So if you like a rule and you've done it for one thing and you want another one that's very similar, you can just copy it and then just change just the things you want to change. And then, of course, if your saving is only going to be if you make certain changes. So let's say I add at the very top and I say, by the way, I want to block absolutely everything. I'm going to block on the LAN IPv4 and IPv6, and I'm going to have any protocol. I don't care what the source is. I don't care what the destination is. I'm going to save that. Now, you'll note right away that it went below the anti-lockout rule, even though I asked for it to be put on the top. This is a rule I usually put down at the bottom, because after I've specified my rules that say what I will allow, I then have this rule at the very bottom to say, okay, if you didn't hit one of the rules that you specifically allowed, don't allow it. All gone. And I'm going to take this one, and I'm just going to take it, I'm going to move it down to here. Technically, I should have added it at the bottom, but I sort of want to show that you can move it. And by the way, once you've moved it, you want to click save to say save that it's down there. So here is where, and what this does, by the way, is it says nothing is allowed in and nothing is allowed out. So I'm going to have to go, if I want to be able to do anything, I'm going to have to add some rules to it. And so I might add at the very top to pass IPv4 per TCP protocol. I might say anybody on this particular LAN, I'm going to allow to any port, and I can have a destination. I could just say HTTP, HTTPS. And you'll note here that I need to make an HTTPS rule, and I'm going to save it. Oh, look, there's HTTPS. And then I'm going to do a Same thing, LAN, TCP, IPv4, a destination port. I'm going to allow you to go out on HTTP, and I'm going to save it. Well, you know, this gets really kind of old because now for everything you want to have going out, if I want to allow SSH out, I'm going to need port 22. If I want to allow some other thing out, I need to do this for every single port, and it's kind of hard to read. I can see I got port 80, I've got port 443. So this is where I like aliases. And instead of these, I'm just going to delete these real quick. We did make an alias rule. Oops, I didn't want to disable, I want to delete it. Yes, we're going to delete that one. And we're going to delete this one. And instead, at the very top, I'm going to do a pass LAN TCP to this says from any local source. So anything on 192.168.1, whatever this particular subnet is, destination any. And now, instead of destination port range, I'm going to select, I believe I called it TCP, allowed outgoing TCP. And I'm just going to use that, and I'm going to click save. And now I'm saying I'm allowing on TCP from any port on this subnet, or on the LAN subnet, to any destination, I'm allowing these ports. And if I click on it and say, oh, it's 80 and 443, and I can just add whichever ones I want. And then you're going to click changes. So this, very simply, is the way that you're adding your firewall rules to say who's allowed to go where. And we'll talk more about that in a little while when we have multiple subnets going on. Let's take a look at DHCP. That's going to be in the services, and services are going to be two that we're interested in. One is going to be the DHCP server. The other, eventually, when we get to that, is going to be the DNS resolver. Let's start with the DHCP server. If we click it, right now we only have a LAN, but for every single subnet that you have defined, you'll see an option to run DHCP server. This is now the default is the Kia DHCP, and you want to make sure it's enabled. And your first option is deny unknown clients. And here, if you have the MAC addresses registered, then it will only provide DHCP services to known MAC address clients, which is somewhat, I don't know. Maybe that's worth it, maybe not. Let's face it. If you hook yourself into a subnet and it isn't giving you a DHCP, you could just set your own. So it's not that much of a security advantage, but it's certainly there if you want to use it. Here I've set the subnet to be 192.168.2.0/24. So that means that from 1 to 254 are the legal address ranges. And this is kind of nice. You can say what you want your address pool range to be. That is, what are the addresses that it's going to give out? And you can use it from 100 to 200 if you want. You can basically set them to whatever you want. I kind of like leaving the bottom addresses not available to DHCP. That way I can put services on there that I know I'm going to want to have that are in an address range that are separated out. So if I have some kind of a service, if I have a particular machine that I might want to get to, I'll put that down in the 2, 3, 4, 5, and makes it much easier to go and keep those separate from machines that, if it's a DHCP, you really, you're going out from it, you're not going into it necessarily. Here you can set up I'm not going to talk about the Win server, the DNS server. By default, it's going to use the firewall itself. You could set up to have some particular subnet use a different DNS server. I don't know why you would, but you're free to. The gateway. By default, we've set the firewall to be the gateway. You could set another machine to be the gateway if you wanted to. I have never used that here. I have separated gateway out for individual machines, particularly when I've got a VPN running. I may want a machine to bypass the VPN, or I may want a particular machine to use the VPN. Then I'd be using different gateways. So I'd either say, well, we'll see that when we get to that later. You can specify an NTP. Remember, this is the timeserver protocol. I'm not going to talk about the other ones. And this one matters if you want to have down here, if you want to have a static mapping. That is, you want a particular MAC address to get a particular IP address every time. And again, this is useful if you want to say, I want a particular server to always get 192.168.2.5, then you'd add a static mapping. And in the static mapping, you basically specify the MAC address that you want to have, give it a name, tell it what IP address you want. This will have to be the 192.168.2. something for this particular subnet. You can have a host name with an ARP table entry. This will let you go and look up the name later. And for this, now you can have a DNS server or a gateway for this particular IP address if you want to be doing that. So you can have each IP address be given a different domain name server, a different gateway, whatever you want to have. So you really have very detailed control. For the most part, I'm going to suggest you don't use this unless you have probably the primary example of this would be a printer. I want my printer to be on a particular address all the time. That way I know where it is. So I'm going to have my printer be here. And that would be where this comes in useful. So let's take a look at DNS. We're going to find DNS under Services, and we see both a DNS forwarder and a resolver. A forwarder simply says forward the results from another DNS server. So if you don't want to run your own, this would be a great way to do it. So everyone can ask for DNS locally, and this will just go and ask the remote DNS. But if you want to run more advanced things, for instance, DNS blacklisting, which I very much recommend, then you'd want to have your own resolver. So in the resolver, it's automatically enabled, comes by default, automatically has a write listening port, and by default, it's being used on all networks. So by default, it's going to work pretty much just the way you want to have it on your own. And I'm going to suggest that unless you have a particular need, you just leave that as is, make sure it's enabled, and make sure that you can use it correctly. The one thing you want to consider, this is probably the one thing that you use a fair amount, is to add host overrides. This is a way that you can give DNS names to computers that are on your local network. And so you might have some kind of a server or some kind of a printer or anything like that where it's got a static IP internally, and you can just have a name on it. And this is the place where you would do it. So you can go here and you can basically have your printer and you give it the IP address that it sits at. And anytime you now do something to printer, it knows what its IP address is. And these would be internal resources that the DNS resolver can't get from an external source. The other time that you might want to be using this is if you're using a computer that is available both internally and externally. That's where you're going to use something called the demilitarized zone, most likely. We'll talk about that in just a few seconds. But it's going to be usually I recommend, and that's the normal practice, is to put any computer that is available externally on its own subnet. It's isolated from everything else. You have to make sure that all your security is nicely up to date. When you're running your own Dropbox, you want to be able to get to that Dropbox from the road, so you have the ability to access it from the outside world. But if you're sitting internally and you want to access it, you don't really want to go out to the outside world and come back in and go back in. It's already inside. So here's where you would say, oh, that server, just go to it directly from the inside. So let's give an example here. Let's say that we have a domain name, as an example, abc.com. You're not going to get abc.com, long since taken, but it's as an example here. So I might have cloud.abc.com as the subdirectory that points to my Dropbox inside my DMZ setup. So if you're out on the road and you do a https://cloud.abc.com, it's going to go to my internal Dropbox, which is great. But if I'm inside, if I'm at home or in the office, then I want cloud.abc.com to go straight to the DMZ without going out to the outside world. So I don't want to have my DNS resolver go out and say, what's the IP address of cloud.abc.com? I want to say, oh, by the way, and I'd go right in here, and I'd actually go in here and say, cloud.abc.com, and that'd be cloud and abc.com. And here, and I say, oh, by the way, and it's on whatever the IP address is of my DMZ subnet, to say go straight to there. Now, if I'm internally, I'm going to go internal network directly, no overhead going out and back in. And if I'm on the outside world, it won't see this because this is an internal DNS resolver. So in the outside world, it's going to use the normal resolving methods to say, oh yes, that's actually a server over there. So this is going to be important if you want to be having servers that are accessible both internally and externally. And for me, I use that both for my cloud, and I also use it for my security, for my video security system, so that I can see my events internally and I can see my events externally if I need to. So that's the DNS resolver. Let's talk about machines that you want to have access to outside of your home. For example, if you have a Dropbox, you may want to access it internally inside your network, but you may also, while you're on the road, be able to access your data from wherever you happen to be. That would be one machine that you might use. You might also want to be able to access your security camera video footage. So if you're alerted to an event of some sort, you have the ability to go and look at what happened no matter where you are. So there are a bunch of things we need to do to set that up. But none of them are very difficult. They're just a bunch of steps. So the first one is that you're going to need to be able to get to your public IP address. That's the IP address that was provided by your internet service provider. If you've gotten a static IP address, well, then your life is easy. You can just take a domain name that you own and map either it or a subnet to that IP address. So if you happen to own abc.com, you could have mydir.abc.com point to your public IP address. If you have a dynamic IP address, then you need to have something that maps it for you. Some service providers will very, very rarely change your dynamic IP address, in which case you could just map straight to it. Others will change it frequently, some even on a daily basis. For the frequent ones, you'll want to be using a service that's called Dynamic DNS. And here you can basically set up a dynamic DNS where you'd go to a provider. These are generally paid providers, not all of them. So for instance, DynDNS does have a free service if you update it often enough. Where you can basically get a mydomain.dyndns.com that will point to your public IP address. And these services basically use a script that's run by, in this case, PfSense, that will regularly go and contact the dynamic DNS server and say, oh, by the way, this is a current IP address, so that the DNS server, anytime your IP address changes, the dynamic DNS server will see that it changes and remap the name. So this is an easy way to get a static name that points to your dynamic IP address. That gets the first step done. You now have a way of getting to your public IP address. mycloud.abc.com will now point to my public IP address. But there are still a few more steps. The second step is to take your servers and put them on a subnet. Best practices say that subnet should be isolated from your internal LAN because external requests are coming in there. As soon as you open a machine up to the world, you're going to get hack attempts coming in continuously. It's the only way to describe it. So you want to do a couple things. One, you want to make sure that only the ports that you allow are allowed in at all. Two, that machine is well secured. It is up to date. It is running only the services you need, and those services are applicable for dealing with all of the attacks that go on every day. Both of the services that I'm going to suggest are robust and capable of dealing with that. However, there are others, and you should obviously choose the services that you feel comfortable with and you know are able to deal with today's environment of continuous attacks. So the next step is going to be to define your subnet. Here I've taken a subnet and I've called it DMZ, demilitarized zone. That's sort of the standard name people use, where it lives on its own, is accessible from the internal and is accessible from the external world, but really it's just this thing that sits in the middle. That's why it's often called demilitarized zone. And for this interface, we're going to go make it a static IP address for this particular configuration, and we're going to give the some static name 192.168.1.9, or let's do it, sorry, 99.1, for example. So I've got a subnet that's got 256 possible hosts on it, and this one is called .1, and it has no upstream gateway, and we're just going to save that. So I've just defined a subnet that is called DMZ, and it's going to be 192.168.99. whatever you want to have. And once I've done that, I'm obviously going to want to have a DHCP server there so that if I plug something in, it will set up a IP address for any particular computer I plug in there. Chances are very good that I'm going to want to make this be every device that I put in there. I'm going to want it to have the same IP address all the time. So I'm going to add a static mapping, as we've talked about before, where I'm going to say this particular MAC address is, I'm going to call it my Dropbox server, and it's got this particular IP address. So that's what I would do once I have that. The other thing I would do for convenience is I'd add you can see here I have a security camera, which is 192.168.5, but I could very much want to have something, I'm not sure what I'm going to call my Dropbox, but I'm just going to call it data server, and it's going to be a host, and I'm going to give it the IP address of 192.168.99 because it's on the DMZ.6, whatever that is. And this, by the way, is just setting up an alias in the firewall. So from now on, I can just refer to data server, and whatever the IP address is that I've chosen, it will go through and save it there. And that's just a convenience. And the reason I need that convenience is because next I need to go and map ports. So for a data server, the two ports that I generally want to have are going to be HTTP and HTTPS, and that's it. And the reason is, if you think about Dropbox and the next cloud is going to be the thing I'm going to be talking about, that's a personal Dropbox or a corporate Dropbox, it's available on HTTP and HTTPS and nothing else. Now we need to set up the network address translation. This will be the mechanism which allows a port 80 HTTP or port 443 HTTPS to get from our external public IP address to the port of the data server. And for that, we're going to use, in the firewall, we're going to use NAT, which is Network Address Translation. And specifically, we're going to do a port forwarding. We're going to forward a port from the public IP address to a private IP address. So we'll just add a rule here, and we're not going to disable it. The interface is going to be the wide area network, IPv4, protocol is TCP, which is both HTTP and HTTPS. The destination, that's where the original access is going to. It's the WAN address. So that's you're doing HTTPS mycloud.abc.com. That's mycloud.abc.com. And we're going to do two different rules here. One is going to be HTTP. And you'll note that we could take any port we wanted to. So we could get sneaky and say, oh, I'm not going to use port 443 for HTTPS. I'm going to use port 2043, for instance. And so we could actually put some other port here, 2043, if we wanted to. And that slows the breaking in attempts a little bit, but not a lot. because plenty of places scan all the ports and it's pretty quick to see, oh yes, that's an HTTPS port, and they'll just go and attack you from there. So security through obscurity is not generally a great rule. So I don't bother. I just let them come in direct from HTTP, and it's going to go to a particular address. In this case, it's going to go to my data server. And here we're going to have this, the redirect port is going to be HTTP. So it's from the WAN address HTTP to the data server HTTP. And we're going to save that. And then we'd make another port, another one just like it, where we'd have IPv4 WAN, protocols TCP, WAN address, and now we'd have HTTPS. And we'd go to the alias data server, and redirect target port is going to be HTTPS. And now we have two rules where they're basically going to be the destination port of 80 is going to get mapped to the data server destination port 80, and similarly 443 is going to get mapped to the data server 443. And this, once we hit apply changes, will take any access to the externally visible, the public IP address on these two ports and map them to this machine that's in our DMZ on those ports. So that machine is now accessible from the outside world, which I'll just say again means that security must be a top priority for that machine. And the main ways that I do that is I run an operating system that is known secure. I really like Linux for that. Even though I've got a firewall here that's saying only allow these ports in, I'll usually run a little firewall in this thing too, just to double check. And this machine can be accessed from the outside world and from the inside world. So that means that you now have a place where you can put your data server, you can put your security camera server, you can do anything of that sort and get at it from inside, get at it from outside. So for your security camera, your security cameras can go and talk to your security camera server, and it can record everything. And then you can access those recordings and be notified about events occurring and see them both internally and externally. So that's the NAT forwarding. The only other thing you'll need to do then is to have any other rules available. So when you want to access your data server from inside, you'll need to basically have the rules set up here within the DMZ. You'll need to be able to basically say, we're allowing in other ports. And that's more or less it for getting access to a machine. Setting up that machine is what we'll talk about in the next video. So we've now covered the concepts of setting up a firewall and setting up a router so that you can have your own subnets and you can control who has access to what from where. And that's great. If you are particularly security concerned, then you may want to be looking at a few other things. We talked a bit about allowing port 80, port 443, external from outside the outside world into specific machines at specific times, and that's great. But that does have some security risk. Shouldn't be very high if you've configured everything correctly, but it's nonetheless there. Anytime you open any port at all, you'll be getting nonstop attacks, mostly from bots, but just people trying to get in to your machines. And there's ways to slow that down a bit. One of them is by setting up a VPN. PfSense does allow you to set up a VPN, so you can have any client access your internal networks only through a VPN. That means the client will log into PfSense and use whatever security protocols you care to have. And if this is of interest, I could make another video just on this because it's a fairly complex topic. But that would basically allow a laptop on the road to be given an IP address in the subnet that you specified. Everything encrypted. So that laptop is now acting as if it's inside your network, even though you're on the road. And the VPN is responsible for two-factor authentication in order to set it up, and then full encryption in both directions so that nobody outside can go and look and see what's happening. It's almost as if you take your laptop and virtually plug it into your internal network so that you have access. It's going to be slower, but it's there. An easier method, if you are running with a Linux machine somewhere, is to run an SSH server. That's a secure shell. And it's just a very simple way of having a laptop that's on the road, open up a log into the Linux machine inside your network. You can disable username password and use only a key, and then use an authorized key so that that particular laptop has a known authorized key that is allowed into that particular Linux SSH server. It's a lot simpler to set up. It works great. You can now tunnel any ports you want through it, but it's not as flexible in terms of getting at different ports from different machines. You sort of have to say, I want to have this port forwarded from that PC, and I want this port forwarded to that PC. It's a bit of a list you got to keep track of, kind of a pain. And you also have to manage a list of authorized keys. And the authorized keys, each laptop will say, okay, this is my public key, and you got to take that public key and make it an authorized key on the server running a secure shell, SSH server. So it's a bit of a management headache. It's easy to set up. It's got its advantages and disadvantages. If you only have one or two people doing this and you only need to get access to one or two different sites, I want to have HTTP access to my cloud server, I want HTTP access to my video server, well, SSH will work just fine for that. On the other hand, if you've got 10, 15, 20 people trying to log in and they all want to get to different devices on your internal network, then a VPN is called for. With that in mind, we've set up the basics for your firewall and your subnets. Now the big task is to decide what kinds of subnets you need, what devices are going to be in each of those subnets, who has to talk to whom, what should be allowed in, what shouldn't be allowed in. And that's a bit of an architectural trick. So that depends on your security requirements. It depends on the kinds of needs you have, how many people are using it, so on and so forth. And unfortunately, I can't help you on that one. That one you have to figure out on your own because it's really user specific. In the next video, that's video 4 of the series, I'm going to go through setting up a cloud server that's going to live somewhere on a subnet that you're going to set up here. And then the 5th video will be on setting up internet cameras that talk to a video server that records everything from your security cameras and can alert you on when anything happens. And there too, you'll have a variety of different trade-offs. You put a dedicated Linux server that's running the software and all of the IP cameras on one subnet. That's great. That'd be the most secure, but it requires having a Linux server just for your IP cameras. If you're running a home environment, you may decide that you are going to share one Linux server to run both your cloud and your IP camera software, which means you'd probably still put the IP cameras on a subnet, but then allow them to talk to the server that's on what's likely the DMZ, the demilitarized zone, where you have your Linux server that we'll talk about setting up in the next video of the series. With that in mind, the next 2 videos in the series might be helpful for figuring out what it is that you want your network to look like.